Good day. Welcome to this video. In this video, I will be explaining how to integrate ICRC payment, ICRC-1 token standard payment into your ICP project, including internet identity. So let's get started. Yeah. So yes. So I'll be talking on ICRC-1 payment today. Let me get this sorted out. Okay, so yeah, my name is Netrob or Israel. You can call me Netrob, and I've been working on ICP for quite some time now, almost a year. So in this video, I'll be introducing you guys how to integrate ICRC-1 payment into your project. It's not hard, it's actually very easy. The purpose of this video is to use a particular use case, a very familiar one, to try to explain how you can accept ICRC-1 tokens as a kind of payment for a service on your platform. Say, for example, on the project you'll be working on today, you want to allow a kind of payment for a service model where users can pay certain amount of tokens to get a certain amount of how would I say a certain amount of access to features on your platform that you want to use. So that you accept. So let's just dive in. Let's dive in. Yeah, so yes, what is ICRC-1 payment? In the ICP, we have three token standards currently. ICRC-1, ICRC-2, and ICRC-3. ICP itself was designed before the token standards were implemented or agreed upon. Right, so ICRC-1 payment allows for you to perform certain actions on the ICP network. So let me bring up that. So yeah, so here is it. So you'll be able to use methods like ICRC-1 name, ICRC-1 symbol, decimals, fee, metadata, total supply, maintain account, balance of transfer, which is what we'll be using and very, very important in this video. And then the supported standards. So the difference between ICRC-1 and ICRC-2 is that in ICRC-2 standard, you can use something called transfer form. So let me try to open this up. Let's think about this logically. So you are building a particular website, and on the website, let's say we want to accept, we have different, first of all, the goal is to try to think about it agnostically without thinking about ICRC itself. So what do you want to achieve on your website? You want to, let's say, sell. Now let me use a different use case than what I'm using today. So you want to sell an e-commerce product, or you're an e-commerce website and you're selling different products on your website, right? So this is the buy button here. All of this costs different prices. Let's say this is $7, this is $3, and this is $2. We'll be using tokens in the actual sense here. So first of all, when we say ICRC-1 tokens, we need to understand that it's a standard, right? Meaning that any token or any contract that follow that particular standard can be called an ICRC-1 token because, well, you can use the methods that are available in the candid also on that particular token. That means you can also call transfer, you can call balance of, you can call name, symbol methods on that particular token and it's going to respond to you. So the first thing you might be thinking about is that if you're actually approaching this by yourself, that, oh, would that mean that someone can come to my website and pay any token? No, 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 that doesn't mean. What it means is that you can, if you implement a kind of way whereby you can accept an ICRC-1 token, it means that you can just change the canister ID of the token you want to accept. So today you might be accepting CKBTC, and tomorrow you can change it that okay, you want to start accepting maybe CKETH, right? That's it, right? And you can also configure, let's say you want to actually go extra mile to ensure that you can accept multiple payments at once. That's also very possible. So now let's say in this particular case scenario, we want to CKBTC is ICRC-1, So it supports ICRC-1 token standard. So let's say you want to accept CKBTC payment. What you need to do is very simple, right? But let's think of it like as if we don't know what ICRC-1 token is. So what you would normally want is that a particular user has, let's say this is 7 CKBTC, 3 CKBTC, and 2 CKBTC. Let's say a particular user in his wallet has 10 CKBTC, right? 10. Now, he wants to buy this stuff, and you are the seller, right? In your account, like you want money to enter into your account, right? And you want ICP to facilitate this transfer. What, if you think about it logically, what does need to happen is that the user comes on the website, the user connects something, like you have to have access to their wallet one way or the other. Normal smart contract on Ethereum, you would connect maybe either your MetaMask wallet or any other kind of wallet you have, right? You connect it on the website. And after connecting it, when you click on buy, what happens when you click on buy is that this initiates a new transaction. It creates a transaction for you to sign. And the way you can sign it is using your wallet that has been connected. So you use your MetaMask wallet to sign this transaction. You would see the transaction details. You see, okay, how much you want to charge me so that you won't be scammed, right? All these are important. And then when you see those things, which is very, very important, these are key important things I'll be talking about later on implementing ICRC-1 payment on ICP. So now you see how much you want to charge. You want to buy this particular item. It's 3 CKBTC. Let's say there's fees of, let's say, 0.0001 CKBTC, right? 0.001 CKBTC. So you pay this amount, right? You see it and then you approve it, right? When you approve it, you won't be charged 5 CKBTC because, well, this is what you signed. You can't be charged more than what you signed for. Now, when that is done, the signature is sent back to the website, which is sent back to the canister, and then it checks if that is valid, or smart contract, it checks if that is valid or not. And then, like, you have basically approved 3.001 to be sent to the seller. Correct. And then the site confirms your payment and gives you the particular product you just bought. Either they send it to shipment, if it is a physical product, if it's a digital product, you get maybe something sent to your email. Perfect. That's as good as it gets, right? It's very, very simple. Now, how can you bring this kind of flow into ICP itself, right? Now, it's a little bit different, right? Than from, but it's still the same logic. It's just that the steps are different. First of all, what you need to understand is that this method is very, very important. Transfer, right? One, there are two major key points in this particular process. The first one is that how would you connect the wallet to it, right? So, and again, the wallet must be the wallet or the ledger. We call it ledger in our own case here in ICP. The ledger must be CKBTC ledger, right? If you don't have an account in CKBTC, meaning you don't have any money in any CKBTC in your wallet, then you are not registered on the CKBTC ledger, meaning you have to be there. So now we want to ensure that this user can transfer 3.001 CK or 3 CKBTC, like to keep it simple, the charges and everything will be added to the seller, to us. First thing is that this user must, as I said before, have CKBTC. You having CKBTC means that you are in the ledger already, right? That's the ledger. It's keeping track of how much you have. Good. Let's say this is CKBTC ledger. Now, this is what we need to do. First of all, we want to keep some important things, some edge cases very, very clear. The user must be safe. First of all, the system cannot be tricked, cannot be written in a way to trick the user to send more than they need to send. For example, send 5 CKBTC for a product that costs 3 CKBTC. That is wrong, right? Also, we also don't want to be scammed, right? We also want to know that and confirm that we got this particular amount of money. And there's one important thing. ICRC-1 token standards payment does not have events to notify you when you get money. So normally you would have done it in a simple way, whereby this user sends X amount of money to a particular address. We are notified, okay, we've got a notification using the memo ID. We can, okay, oh, this is the user that paid. And that's all. There's no notification like that in the ICRC-1 token standard. So we have to go through a particular process. There's different ways you can do this, but there's this particular way I want to explain now. So now, um, first off, we need to have our own, well, we need to be able to create sub account. This brings us to the idea of sub accounts. It's very, very important to understand this. In the ICP, in the ICP CRC ledger, you can have thousands, billions of sub accounts connected to a particular principal. A principal, you can also term it a wallet address, or it's an identity. It's you. That is your signature, right? That's your public key. You can call it anything you want to call it, but the principal is you. The principal is connected to all of the sub accounts, and there is, you can have like I think 2 raised power 32, or so it's much, right? It's much. There's enough sub accounts to go around, right? Just for you alone. Other people can also have the same amount of possibilities you have. Now, what you want to do is this, right? We want to follow this particular process, whereby the seller has his own account, right? The main wallet itself. Let me explain what that basically means. I want to just ensure you understand this particular part before we start going deep into code. It's very important. I had to dive deep to find this information and understand them. So now this is the principal, right? The principal can have multiple sub accounts, multiple sub accounts, right? But there's an idea of what we call everything is actually having a number. Like this zero, start from zero, this is one, this is two, right? I'm just using this particular number. It uses binary on the lowest level, meaning you can have 0, 1, 2, and then have 1, 1, 0 right here. The other doesn't matter, right? But then the null, this is the very, very important one, the null one, right? If you are trying to transfer a token on the ICRC and you don't pass a sub account identifier, it assumes it's going to be the first one, which is this null one, zero. It is going to be zero. I think it's 32 characters. It's going to be 32 times. That's the identifier of this particular account. And this is that. This is actually the main wallet. Now, as a seller, we want to ensure money is transferred smoothly, the accurate amount. We can't transfer money for the user, right? That's the first thing you need to understand. When I first started the project, I thought I can transfer money from the user, but it is ICRC-2 standard asks that particular method where you can call transfer from. The user approves a particular amount of money for you to transfer, and then you can transfer the amount from the user's wallet into your wallet. That's straightforward, right? Very, very smooth. But this one is you have to go through kind of different method, a different approach. So yeah. So now this particular one comes right here. You have your normal account. Now let's create a new one. Right? This user comes to the website. He wants to buy something. Let's create a sub account for him. We give him sub account one. Let's assume this is called one. Right? Now, all this guy needs to do is just ensure that he sends this particular amount. It's not going to be this kind of art. There has to be a kind of user experience here. When he clicks on buy, he sees the address is going to send money to. You can either do that, and then he sends it to the address, and then maybe clicks on I have sent. Or we have a kind of background worker that keeps on checking for whether money has been sent to this particular sub account. Or better still, we use the user has a self-hosted CKBTC wallet address, an NNS, if you can call it that way, right? If that's the case, then that means that we can use this, we can write a kind of logic into the React project using the ICRC-1 ledger package in JavaScript to, first of all, using the internet identity, the user can connect to the wallet or connect to the ICP itself, right? Giving them a kind of signature. Using that signature, you can make calls. The user can make calls to the ICRC ledger without needing to, copy the address of the sub account and then go into their wallet and send in that. Meaning that when they click on buy, what we can automatically quickly do is that we can just call transfer. ICRC-1 has transfer, right? So we are good to go. So we call the transfer method. The user is calling the transfer method actually, not us, because we can't call it on behalf of the user. The user has to be logged in and can actually call that. So now we call transfer. So what we need to do is this. We transfer 3 3 CKBTC into the sub account, right? It sends it from 3 to this particular one, right? That is successful. If not successful, we'll get an error if that is insufficient funds. We can see from here the errors should be listed here. So these are the kind of errors you can get. So it could be insufficient funds told. There's a lot of logic behind this particular transfer method whereby you can't transfer money in the future, you can't transfer money if it's too much in the past. There's a kind of limit or a kind of set of time, or I would say a kind of start and end time you can use, right? So but that's not important to us. So now the user sends 3 to that. The user can confirm that he sends 3 to that. That's first thing. First. Now the user knows he sent 3 to this, right? But now we can't just say, okay, if it is true, then give user that. No. We have to also legitimize this particular transaction on the canister itself so that it stays in the ICP itself on our own side, right? Keeping records. So now the way we can do that, and which makes very, very absolute sense, is that if this user actually sends 3 CKBTs to this, that means on the second call to the canister that we have built ourselves, the dapp itself, right? That means that we should be able to send 3 CKBTC from this particular sub account to this main account. If we can't send that, then that means that either the user did not actually send 3, they sent 2. They sent anything lesser than that, right? Which would mean that it won't, then this would be impossible, it won't work. That second call is what solidifies and allows us to also be able to be assured that we are not scammed and we're not just giving people product just like that, right? That second calls validate that particular part. It notifies us, and then that particular transaction of sending the CKBTs from this sub account to this sub account proves that 3 CKBTC was sent by this user. Now, all of these things is simple. It's simple in the sense that the user sends 3 to the sub account wallet. They don't even know that it's a sub account wallet. All they know is that they are paying money to the particular website. But the logic behind it is that after they pay to the sub account, another query call, update call is made to the canister that debits the sub account and sends the CK basis to this main account. If it is not successful, then that means something was wrong in the first call, right? So that is how it works. And now let's dive into the actual process, how it is going to work. First thing you might think is that, oh, are we actually going to be using real CKBTC? No. First of all, no. We'll be launching our own token, our own wallet, right? And yeah, we'll be launching our own wallets, our own token, sorry. We'll be calling anything we can call it, right? So that we can test locally. We can give ourselves funds, give the user funds, give the seller funds, an account, and then we can use it normally. The only difference to make when you're going live is that just change the canister ID of the token you're using to a token that supports ICRC-1 token standard. That's just as simple as it is. So now, after that, next important thing is that you need to have DFX deployed on your system, right? Now we'll be diving into codes now. So you need to have DFX installed so you can use the you can use the DFX commands like deploy, generate, and so on and so forth. Also, we used some dependencies that are very, very important on this particular project. First of all, we want to ensure that our canister is stable. So I used Vector. Vector is a very popular package on MOPS. Yeah, so this is Vector right here. This is the MOPS dependency. So this is the ICRC-1 types used to ensure that yeah, I can quickly use the types without having to actually have a kind of code writing out my own ICRC-1 token standard. I don't need to do that. The goal of the of this video is to ensure that you understand how to initiate that transfer. So vector ICRC-1. This SHA-2 is, I'll explain what this is going to be used for. This particular important method in generating the actual account identifier. You won't be passing principal and the sub account. There is a particular string that you can use to identify each account uniquely. This SHA-2, there's a particular algorithm there, SHA-256, that is used in a way to generate unique sub accounts for each user. Like I've said, you can create many sub accounts, billions. There's no limit to it, right? It's there's limit to it, but it's billions, right? So you can create one unique one for each user that's coming in your system, right? And then they can send money to it, and you know that they're the one that sent money to it, and because only them can send money to it because it was created for just them. So now that is that, let us move into the code part. So this project is split into two parts. It's a monorepo. There's the back end and then there's the front end. The back end is three important, actually four important. Let me just open them together. Four important files. I'll be going through the very important ones. So now let's us look at this. The first important thing here is that first of all, this is a project, this is a blog project where users can pay certain amount of tokens to get access to certain amount of services or certain features, right? I'll be running this. So I think first of all, I need to run this first. So we see how it works. And then I can start explaining how you can go about integrating it on your own system also. So DFX, oh sorry, CD, DFX, okay. Let me deploy it. I've already run the DFX local replica in the background, so this can work fine. Okay, I don't use too much time. This is so amazing in such a way whereby you don't even need to learn how to integrate multiple wallets, right? As long as the user's identity is connected to any of their wallets, you can use a self-hosted logic in order to be able to transfer funds from the user's account into the sub account itself, using by getting the user's permission, of course. You can do it yourself. So now let us save, start. Okay, here we go. So I'm running this already. I use the starter. I use the DFX starter to do this. So now I have articles here in this particular project. Looking nice, right? So there's already 6 articles here, right? We have how many members? We have 2 members, Luca and Netrub. We have profile. You can't actually check a profile until you are logged in. This is where the internet identity comes into play. So now you can log in by we use internet identity to ensure that you can log into your account. So you can pick any account from here. Let me choose this one. So this test only. If you're actually using the live internet identity, you will need to enter maybe your fingerprint or Face ID to allow authentication. So this is Luca. Luca is a free user. So there's a concept of free, elite, and legendary users. So the free user can post 5 posts. The elite users can post 50 articles, and then the legendary users can post unlimited amount of articles. So let's check how many articles Luca has posted. Luca has posted 1 article alone. Luca can create a new post as a new YouTube post, and you can also use Markdown here. It's yeah, that's really nice. Nice things going around. Luca is here to stay. Okay, so now we have this, and then we can save this. Oh, yeah. There's kind of limit to the kind of amount of content you can add. There's kind of requirements. You need to at least have 100 characters so people don't just post randomly. Anyhow, so now let's click on save. Yeah, a query is made to the backend that saves Lucas post. So now this is Lucas post here. Lucas can post more than 5. Now let's go into the part of the settings. Yes. So this is where you can find your plans. There's a lot of things going on in the background. A call was made to the ICP ledger canister, not using the canister itself, connecting to the deployed token, meaning that we are using CKBTC, the front end is actually using ledger ICRC package to connect to that particular actor and make query to that so that it gets the information, right? There's no need to go through us to that, right? That's too much journey. So yes, so you can see the current plan is this 0. So I don't know if Luca actually has any money on ground. So let me try to upgrade Luca's account to Elite. So this makes the call in the background, and then you can see Luca does not have enough money on hand to make a payment. Now let's just check Netrobe. That's the second identity I have. I think that's this. Wait, I think that's this one. Okay, that's not this one. I think it should be the first one then. Okay. Okay, I don't think that's the identity itself. Issue. I forgot the identity. Okay, that's it. Netrope. So it's logged in successfully. Netrope is already a legendary user, right? Legendary user, he has money. So now, how is this possible? There's two first important things that you need to understand from this particular part. The first part is, I said, launching our own local token, DJTK, and I was able to do that using the ICP documentation, very documented, highly documented. So if you come right here, maybe I'll drop some references in the after the video so you can get them out. So right here we have looking for, yes, this yes, right here ICRC-1 ledger setup. So this is the important part. Yeah. So I used the first of all, you need to actually, in order to launch the canister itself, you need locally you need the code for it. If you don't have the code for it, you can't launch it. So in ICP, we use WASM and Candid. Candid is so that you can have a kind of UI where you can make queries to the ledger itself without having to write code to do that, or using the CLI. And WASM is actually the code binary itself. So this is the token, right? This is it right there. So deploying it is where this particular part comes in, right? You would set the token's name, you set the amount, you can even set the initial owner of the token itself, where you can give that person minting. You can mint like, I don't know, 1 billion DJTK or anything you want to call it. You can mint that up right there and then give them any amount you want to give them. So this is the code right here to do that, right? Yeah, everything is right in the documentation. After you have launched that, you would set the initial values. You would give yourself, I recommend you give yourself a lot of that token so that you can send part of it like kind of test user like I did for Network. So now after you have done that, all you need to now do is make simple calls um to the ledger canister locally to send some tokens to the, yeah, like to your wallet, to your user. So let me take a look at that. So you know the way wallet works on, or ledger works. Let me not call it wallet. Ledger works is that if your principal does not exist on the ledger and you try to send, you exist on ledger already once, and you have a particular account or money on it, and you send token to that user. The user does not need to actually go to the process of actually, okay, before you can accept CKBTC, you need to create an account on CKBTC. No, you don't need to do that. When you send X amount of money to that particular principal, it is recorded on the ledger already in CKBTC, in CKBTC, that this user actually has an account and has money in the account. That's just it. So there's no hassle on creating anything. So let's get yeah. So what I can do from here is Normally, I would have locally used the state machine here. That is, you have to get the user's principal. After getting the user's principal, I'll be able to actually know the actual value, and then I can do this dfx canister. I think call, oh shit, canister call. I can like call the canister itself. Actually, I think I deployed it right here. I don't want to use the CLI to do that. So I deploy it right here. I should be able to also call it from coming. This is the canister right here. So yes, I can call it directly from here without, I don't need to use the CLI itself. So all you just need to do is grab the token. Let's say you created a new identity, you grab the principal of that user, and then you come right here. Actually, you need to use the CLI because the identity can't be used there. First of all, I think because this is test environment, right? So let me get this. You can use this one to get this anyways. You can use it to get you can use it to get a kind of same sub account stuff I was talking about. So you can use this to get a kind of yeah. So it was rejected, definitely. You can use this to get the kind of data that you want to send. So let me get that. Yes, this is it right here. So now let's call that. Let's call that. Canister call ICP ledger canister, get the name. I called mine ICRC-1 ledger canister, which you would be configuring when you are setting up the DFX right here. So this I'm getting the name from. ICRC-1 ledger canister. ICRC-1 ledger canister. Yeah. Made a mistake. I'm confusing ICP ledger with ICRC-1 ledger. Yes, that's right there. Dev journey token. And now I want to transfer all I need to just do is call ICRC-1 transfer. I need to set this is where I have issues with this. I have to set a let me get that out. So this is right here, like this. So this is the old payload. Just look at the URL so you can get that from this. The important thing from here is that you're passing the owner, you're passing, if you don't pass the sub account as I explained earlier, you're going to use the default account. So now let's grab that and then let's come back here and paste it out. Good. Beautiful. So this won't work, first of all. Actually, it will work if it is a valid principal. So don't send, if you're actually using the live account, don't just put any principal there. You won't get your funds back. It's going to go to that principal. As long as it's a valid principal, even though it does not exist yet, it's going to go to that account and then it's going to work. So, yeah, so this is a test. This is a test scenario. You can see it went straight to the account. I don't actually have this account. I don't know this. I don't know this principal. Normally, what I've done is that I would have used maybe console log to get the principal of my user, so I can send that user token, so that they can then, in a normal world, would already have that token. I don't need to do the sending, and then they can buy it. They can buy the services on the blog. So that's actually that. So now what I'll do here is that let me get the canister. Let me get the principal ID of reduce this. Let me get the principal ID of let me get the principal ID of Luca so I can send something to Luca and then use Luca's account to pay for the services. right here. Yes, looking for the login page. Okay, yes, login. What? Login. Put login, login, login. Correct. So this is right here. What we can do is we can console.log principal, and I can say identity.getPrincipal right there. So using this, you can then log in as Luca. You can find out what Luca's identity is, and then get that out. So let me inspect. Uh, Let me inspect, and then let's okay, good. And let's log in. This is Luca. Yes. Okay, so oh shoot, I should have used the X method. Get principal to text. So you can actually copy it, text version, instead of this one. Okay, so here we have the principal ID. So what we can do now is this. We want to send money to Luca. I'm not planting anything like balance off in the project, so don't worry yourself. All we need to do is ensure that Luca can send and buy stuff from this. So I'm sending, actually, let me send 10 million DGKTK to Luca. Luca has some funds in his account. I did not write that correctly. Yeah, so Luca now has 10 million of this token with him. Yeah, so let's go. Balance of will only give us our own stuff. Okay, so now let's us go right here. Before I tried using Luca to make payments, you see it did not work because Luca does not have any amount in any of that token in his account. So now if I click on upgrade, what should happen is that Luca should be able to upgrade to this. You can see his new balance. Actually, was logging out his balance. You can see that's 10 billion of the token, or 10 million, sorry, of the token. So he's now in this particular plan. Perfect. Luca is now a elite member of this um stuff. So I'm coming, upgrade. Okay, there's a little bit of issue coming. Let me consider balance was never deducted. Let's just debug that. So now we're getting the code, so we can do a little bit of dancing around here. So that will be billing. That will be make payment itself. So yeah, so getting this balance, trying to decode his account. The account you're sending the money to, the sub account. Mm-hmm, mm-hmm, mm-hmm. So I think there's an issue on 182. mention 136, right? Yeah, there is a big issue. So it's not sending. Hmm, that might be because of uh, hmm, things balance. Why not send it also? Oh, I think I know why. Because you should be able to send this right here. This to this, get sub account, get account address. Since the account address has not been set. Yes, account address is set successfully. Then what's up? Here's the account principal with the sub account uniquely added to it. Uh, coming. I think since I deployed this again, I need to do something important, which is set this particular value. Uh, where is that? Token canister ID. This, this. Set token canister ID. So first of all, let me actually get it. Let me see what it is. This area. No. This area. Correct. Okay, now this is it right here. So let us get this. I think this is not set yet. It has been set already. Hmm. That exists already. Why is this not sending to this? Yeah, I went deeper into the error now. It's actually insufficient funds, which is weird. Very, very weird. The balance is 10. This is where I think decimals come into place. I think this is supposed to be 8 decimals actually. I made a mistake. So let me make an important note on this particular part. So when I was launching this particular token, let me query from here so you can all see it. First of all, like I said, it's very important I send enough tokens to that account. So right here we have something called get decimals. Yes, yeah, this one. That is 8 decimals. So in order to know actual amount I have, we need to divide 10 million by 8. So that goes 1, 2, 3, 4, 5, 6, 7, 8. I actually have 0.1 DJTK. So thank God that the when I was minting, I minted enough, right? So you have to mint enough. You need to do some calculations. So if you want to actually, if you want your user to actually have, let's say, 100 billion DJTK or anything you call it, you need to mint 100 billion times one, and the zeros. The zeros will be the amount of decimals you set when you were minting, when you're creating the token itself. So now this is what we can do right here. Very easy. All we just do is send. Now I want this guy to have 100 DJTK actually. So what we can do is that we can send this 000. So that is, this is, I think, this is 9 zeros like this. So this is too much. So this should be enough around this particular point. So okay, so that's okay. Yeah, so I think this is okay like this. This is okay. This is 90. So this is 100 of it. Yeah, successfully. So after that, I was able to debug this because I was able to do something like this. So I said it before, it comes an error type. So the error type told me it's an insufficient fund issues, which pointed me to the notion that the money is not enough, which led me to remember that the decimals is what's causing the issue here. So now let's click on upgrade. So it's going to show us he has enough, and then it's going to be successful as it's supposed to be. So yes, successful. Automatically it changes to this particular plan. You can see right here. No need to reload. And then we can also upgrade also to legendary plan. So legendary plan allows us to send to post infinite amount of articles. So there is that, and there we go. So that is it in nutshell. That is the accepting ICRC payment. Important methods that are used here. The first part, which I said you need to send money from the canister itself. I'm sorry, like using the canister, like you need to connect the front end on the client itself, not our own canister. The client itself, you need to connect it to the ledger canister separately and then initiate the transfer call. So this is how it was done. So there's important on this particular component. The first important one is this. Where is it? Yes, this use effect method, right? It sets up the connection to the ledger canister itself, which is this particular one right here. The ID to ledger canister. So let's say I want to accept CK BTC now. When I launch the deployment, what I will do is that there's a particular method I showed you earlier, which was set ICR supplement. It's available on the Candid UI of the backend canister, which is right here. You can see get ICRC token canister ID, and this is set the, the token canister ID. So this canister actually points to the DJTK token ledger on my local replica. If I'm going live and I want to use, let's say, a token that is like, let's say I want to use CKBTC or CKETH. All I need to just do is come to this particular method live and set that. And only the person that initiated the call, sorry, only person that installed or deployed the canister that has been set there can actually change this value. So I can come and change whatever it means anytime. And then that means that on the particular website here, this will change. You don't need to change this manually. By calling the canister itself, the client can get the symbol, it can get the decimals, can get everything it needs, and the everything it needs to make calls to the particular canister. Sorry to the ledger canister itself. Okay, so here we go, and then that's that on a particular part. And can see right here what it does is that it calls the get method to get the ID of the token to be used. after getting the ID of token to be used, it connects to it using the local host. If you want to deploy live, I would recommend you use a kind of process.env if it's local or production to change this particular value. I will do this before I push again so you can see the live code on GitHub. And then I use the canister ID right here to create. So this is the ledger canister coming from this package right here, this most important package for accepting ICRC payments. Now that we have the ledger, we have the metadata. Metadata is things like name, symbol, decimals, that and that. So I wrote a method here that helps me to extract the symbol from the way ICP canister serializes the thing is not just straightforward. It's not a key to value base. It's kind of weird. Uh, JSON value. So I have to do a kind of logic to actually extract the token symbol and also the decimals from it, right? Which is very important. So and now here is where, and you can see I'm using the decimals right here, which was where I was getting the issue when I was making payments, right? If I'm multiplying it by 10, then actually don't have enough amount of money. What I can do to make this better is that instead of showing error making payments, it's going to show something much more understandable like insufficient funds. That's better. And then this is the call to the ledger canister. Now, very important thing I want to explain here, which was the reason why I used the SHA-256, was this particular method, get sub account. I said we'll be creating a sub account on the our main account, that's the seller's main account itself, right? But things when it comes to creating accounts, we're not necessarily creating an account, we are using accounts. All these accounts, I will say they already exist. We just need to use them. They don't have any value stored in them, but they exist, right? They exist. That's the way it works. If you read the the, the token standard, how you would understand it, maybe you understand it better. So it's just the same way as I explained the way wallet works. You don't need to create a wallet on CKBTC to have to be able to receive CKBTC. All I need to just do is send that security to your principal ID and then it is in your wallet. You can access it since you own that principal ID. You can make calls to the NNS wallet, self-hosted wallet, and then extract your CKBTC from it. So that's how it works also in this particular part. The sub account, I don't need to create it. All I need to do is point to a sub account. And using this SHA-256 method, I can uniquely point to a sub account for every user. Meaning two users cannot have the same sub account, my sub account, or two users cannot be given by the same sub account of my account so that they send money to it so that money won't start mixing. So this is how that works. So get sub account comes here. There's some important thing right here which is also not easy to get online. Yeah, right here. Let me get the method, get sub account. Yeah, get account address right here. So this is how it works. It uses the user's principal ID, which is always unique, to get a sub account to like attach try to connect their principal to a particular map it to a particular sub account on my own list of billions sub accounts, right? A unique one. So what this does is this, right? There's this particular utility here that takes the canister ID and then the person calling making the call, which is going to be this particular canister, the backend canister principal, and the person making the call, which is Luca. So what it does is that using the canister ID, because that's the owner of the wallet, actually, that's why the canister is able to send money. The canister can't actually send money on my behalf, right? Only if we're using ICRC-2, we approve the canister to send so amount of money, and then they can send it, right? But in this particular case, the canister is actually the one controlling the wallet, which is why it can make calls to the ICRC-1 token itself and then it is approved, right? Its identity is the owner. So then now sub account. What I need to just do here is that I need to use the blob to access a particular blob, right? Which can be anything, right? That's what this one particularly does, right? All it does is that it uses three important things. First of all, this particular number 4, it uses this string, can change it to anything. Anyhow, you can even reduce this to just 2, in fact. And then what makes it unique to each user is this particular part here. the principal to blob and then blob to array, which converts the user's principal to a particular blob to an array, which is then flattened together and then converted into a blob again uniquely, and then ash before being converted to a blob and then passed to this particular one right here, which is what gives us this unique value, which is the connection of the canister's ID, and then this identifies the sub account. This sub account used by Luca will be different from the one that will be used by Netrope, the other account identity. So now, after that is done, what happens here is that the user transfers money to that sub account. After doing that, a call is then made to our own canister, the backend canister itself. The backend canister then does this. This is pattern method here. All it does is that, okay, try to send money from that particular sub account for this user. Right? Since I don't need to actually store that value somewhere, I can always get it. As long as I have the user's principal, I can always calculate which sub account I gave them earlier using the SHA-256. And then using that, I can, okay, now transfer money from that sub account to to my main account itself, right? Which is this one right here. So I pass no here to use the main account of the canister. So now money is sent to it already, which is successful. The user is taken to the plan they subscribed for, else an error is returned with the error value, and that is all. Thank you so much for listening to or watching this video, and I hope I've been able to break down the way ICRC payment work itself, right? And then in the code base that I've explained also, it was actually very, very nice. I encountered that particular issue, which is not a bug, but it's a user experience problem. I did not well like for the case of the tutorial, it's also be very simple. So it allows the user to just make payments. What I'll do is I'll just upgrade it a little bit to make sure the error is much more detailed. So debugging is easier. And then that's that. Yeah, thank you so much for listening to this. And what I'll challenge users to do or challenge you to do next is that try to do it in sort of way whereby if you change, like first of all, you make Oracle calls to, let's say, like, when you're charging users, you won't be charging them. You want a particular value in fiat currency, to be honest. Let's say $10 for elite service, $20 for legendary service, right? When it comes to fiat and tokens, the value fluctuates, right? What I want you to do is that you actually charge them dollars in you charge them a fixed amount of value, $10, $20, but then the amount you charge them based on the value of the token, it's going to be different. If you can work on that, that would be very, very amazing. I would like to see your responses. And again, my name is Netrope. You can reach out to me on GitHub. You'll find my GitHub link in the description below. And also, I'll be adding links to all of the resources I used so that you can also get access to them and use them also. And you can also always message me on Discord. I will drop my Discord link also, or my Twitter. I think that's better. So you can connect with me. I'm always free to work and debug projects with any one of you. Thank you so much. Have a nice day.